Alright, today we will be talking about 5.4 complex numbers. So we're going to start with a question similar to our notes from yesterday. We want to solve for x, so we move that 6 over, and we've got x squared is equal to a negative 5. Now up until this point, when you've gotten this to the situation, we have had a no solution, or no real answer. We've always said that word real. And in the beginning of the year, we talked about real numbers and imaginary numbers. This is where those imaginary numbers are going to come into play. If we want to solve for x, we take the square root of each side, and we've got x is equal to plus or minus the square root of a negative 5. We are going to have an imaginary component here. And we'll come back to this problem in a second. So let's talk about the imaginary numbers. The imaginary unit is going to be written as I. Makes sense, imaginary I. I is equal to the square root of a negative 1. So if I square I, if I take a negative 1 times, and I square it, the square root and the square, we know those two things cancel each other out, leaving us with an answer of a negative 1. So it's really important that you remember that. I is representing the square root of a negative 1. Therefore, if I square I can simplify that down to just the number negative 1. So what I want to do is I want to take this negative from inside of the radical and bring it to the outside. You can never have a negative on the inside. Well, I know that I is the same thing as a negative 1. So if I were to rewrite this, plus or minus the square root of a negative 1 times 5, that still gives me a negative 5. Well, negative 1 can be written as I. So x is equal to plus or minus I root 5. And that's what we're going to be talking about today. So we look at the square root of negative 7. If I wanted to rewrite this, that would be negative 1 times 7. Well, square root of a negative 1 is the I component, so that is I root 7. Now I've got the negative root 4. Well, 4 is a square root, unlike 7. So 4 is going to go to the outside if I break it down. So if I broke this down as a negative 1 times 4, negative 1 goes to the outside as I. Square root of 4 goes to the outside as 2. So this answer would be 2I. So what we're going to do is we're just going to start by taking the negative on the outside, and when I bring the negative to the outside, it becomes a component of I, and that leaves us with the positive 12 on the inside. Then we do our factor tree, 2 and 2. The 2 goes to the outside, and the 3 stays over on the inside. Treat I similar to a variable in the sense that the coefficient goes to the front, the variable comes second. So we would do 2I, we would not do I2. 2I root 3, this would not be I2 root 3. So make sure that the coefficient goes in front of the I. Alright, so now we are going to square a quantity. There's two ways you can do this. Sometimes things that easier is just say, well, I've got that quantity 2 times. So I times I is I squared. Root 5 times root 5 is the square root of 25. Well, if we remember from above, I squared is just a negative 1. And we know that root 25 is 5. So our answer here is a negative 5. Now, because we don't have any addition or subtraction here, I could also just distribute that squared sign. So I squared times root 5 squared. And we would get I squared times 5, which again would give me that same answer of a negative 5. So there's two ways you could approach that problem. So that's simplifying. We're going to move on to solving. If I want to solve for x squared, we know to get rid of the squared, we square root each side. And since I'm solving for an unknown value, I've got plus or minus. We've got a negative, so I move the I to the outside, and that becomes a root 9. Well, that's a perfect square, so that's plus or minus 3I. Go ahead and try the next two. Okay, let's look at how you did. We subtract 10 first to get a negative 8. So make sure that you're adding and subtracting right. It's going to make a big difference in the end. Then we divide by 2 to get a negative 4. 4 is a perfect square, which means we won't have a square root symbol left. Everything goes to the outside. We've got a 2. But because of that negative sign, it's going to be a 2i. And don't forget the plus or minus. Over here, we divide by negative 2 first. We want to always isolate that x squared term. And we get a negative 12. It's not a perfect square, but it can be broken down into 2 root 3. Because of the negative, it's plus or minus 2i root 3. So you're going to do everything the same way you did before, but if the number on the inside is negative, now you have an I in your answer as well. Before, if we had a negative root 12, it would have just been 2 root 3, but now it's 2i root 3. And we did talk about solving these kind of equations before as well. If I have got x plus 2 quantity squared, I want to get to that x. I can't get to the x until I unlock the parentheses, which means I have to get rid of that squared symbol. The opposite of squaring something is taking the square root. Those two cancel, leaving me with an x plus 2 on the left. On the right, I've got a negative, so I know I've got an I. The square root of 25 is 5. That's a perfect square. And then because I solved for something that was being squared, it's plus or minus. Then to get x by itself, we move the 2 over, and x is equal to a negative 2 plus or minus 5i. Which brings me to a great point of standard form. When you are writing complex numbers, they must be written in standard form. Standard form is where the number comes first and your I component comes second. So that's a plus bi, which we're going to look at again in the next page. Alright, our next one, we add our 3. We've got x plus 2. That piece is still trapped. We've got negative 12. Now to untrap it, we've got a square root each side, leaving us with an x plus 2 over here. Break that down. Hopefully by now, sometimes you'll start to memorize what these ones are. You've got a 2 root 3. Because of the negative sign, we've got a 2i root 3. Because we took the square root of something that was being squared, we've got plus or minus. Now we move that 2 over, and we've got x is equal to a negative 2 plus or minus 2i root 3. Really think about what can you put together and what can you not put together. Think about like terms. Everything has to be the same to put them together. This one has an I and a radical. This one's just a number, so those can't be combined together. Okay, flip that page over. We're going to take things and make them a little bit easier now. We're going to go to adding and subtracting complex numbers. And as we said before, remember, always write your answer in standard form. That's your number first and your imaginary component second. If I am adding, I'm just adding like terms. So when I look at this, the parentheses don't mean anything here. It's just this piece, so I could actually drop those parentheses if I wanted to. It makes things a little bit easier to see. I've got a 3 and a 4, so that's 7. I've got a 2 and a negative I, so that gives me a positive 1i. Easy peasy. Now I want to subtract. If I'm subtracting that whole quantity. So I'm going to distribute that negative in. So I've got 6 plus 3i minus 4 minus negative gives us a positive 2i. Then back to combine like terms. 6 minus 4, that's 2. A 3i and a 2i gives us 5i. A nice break from all this hard work. Combining like terms, a nice little review there. Now we're going to go to multiplying complex fractions. Making it a little bit more difficult than adding, subtracting. Can't be so easy all the time. We distribute that 2i, so 2i times 3 is going to become 6i. 2i times 3i is going to become 6i squared. So the I is going to be very similar to a variable, like if I was distributing a 2x. Now 2i can't be simplified, but don't forget I squared is the same thing as a negative 1. So I'm going to take out that I squared and I'm going to put in a negative 1. So that's 6i plus 6 times a negative 1, 6i minus 6. Now the only problem here is that my equation is not in standard form. I want to move that negative 6 to the front. So I've got a negative 6i, or a negative 6 plus 6i. Just like distributing a piece, we are going to FOIL here. So all those rules from multiplying exponents and FOILing exponents apply to imaginary numbers. So I'd FOIL 2 times 4 is 8, 2 times I is 2I, minus 12I, minus 3I squared. I've got some like terms I can combine here. 8 plus a negative 10I minus 3I squared. Don't forget, every I squared is equal to 1. So this is really 8 plus a negative 10I minus 3 times a negative 1. Well, that a negative 3 times a negative 1 gives us a positive 3. So 8 and 3, 11 minus 10I is our answer, making sure that it's in standard form. If you are squaring a binomial, anything that has a plus or minus, you can't just distribute in. If we go back way to our front page, we could distribute in this problem because there was no addition subtraction. This is a monomial. You have one term. There's no adding subtracting going on. Back here. Okay, so we have our binomial. That's bad. We can't distribute. So what we have to do is either FOIL or use your FOIL shortcut that you may have learned. Otherwise, we just write our quantity 2 times, 2 plus 3i, 2 plus 3i. 2 times 2 gives us 4. 2 times 3i is 6i, plus 6i, plus 9i squared. So that gives us 4 plus 12i plus 9i squared. So in case you were wondering what that shortcut was that I just talked about, if you remember, your multiplying shortcut is if you have a binomial squared, you square the first term, you multiply those two pieces together, so 2 times 3 is 6, multiply it by 2 to get 12 because you have 2 of the middle terms, and then square the last term to get 9i squared. You don't have to use the shortcut. We FOILed it out. You can FOIL it out. And we can't forget that I squared there is really a negative 1. So 9 times negative 1 gives you a negative 9. Combine our like terms. Negative 5 plus 12i. Hopefully you are not too tired yet, because here comes the doozies. Dividing complex numbers. If you remember, and hopefully you remember because this was not talked about too long ago, like 10 minutes ago, I is the same thing as the square root of a negative 1. So technically this is a square root on the bottom of our fraction. And we know one of our rules is we can't have radicals on the bottom of our fraction. So just like we had to rationalize our radicals, we have to rationalize our imaginary numbers. There is a slight difference here though. What we want to do is we are going to multiply by 1 plus I. So since this is 1 minus I, we're going to do 1 plus I. You're going to multiply by whatever quantity you have here, but you're going to change the sign. So if I do that on the bottom, I got to do that on the top. So on top, we've got 6 plus 6i. On the bottom, we've got to FOIL this out. We got two binomials. 1 times 1 is 1. 1 times I is I. Negative I times 1, negative I times positive I is a negative I squared. Now the reason why we did that, what we just did is we created that factoring method of difference of two squares. I have the same pieces, one's a plus, one's a minus, that allows our middle terms, the I and the negative I, to cancel. That cancels out the radical of a negative root 1, fixing our problem. So, on top, 6 plus 6i. On the bottom, we are subtracting I squared. Be very, very careful with your negatives there. That's minus I squared is becoming a negative 1. So that's really a positive 1 right there. So 1 plus 1 is a 2 on the bottom. I know you think we're done, but we're not done yet. You can reduce. 6, 6, 2. I have 3 pieces. If you are going to reduce, you must reduce all three numbers at once. And luckily in this case they are all reducible by 2. So 6 divided by 2 is 3 plus 3i, and the bottom ends up canceling out. I know. I told you it was a doozy. Last problem for your notes. Looks like we have that radical on the bottom again. So to rationalize, everything stays the same, but that minus is going to become a plus. So that's what I'm going to multiply on the top and the bottom. I've got you started. Go ahead and press pause and see if you can do it all by yourself. Alright, let's see how you did. We FOIL the top. 2 times 4 is 8, plus 4i, plus 12i, plus 6i squared. On the bottom, 4 times 4 is 16, plus 8i, minus 4i squared. Remember, the rationalizing part is to get rid of those i's in the middle so that I don't have any more radicals left on the bottom. So those middles cancel, leaving us with 6 plus a negative 1. Remember, is that I squared. So negative 4 times negative 1 is a positive 4. On top, we combine like terms to get 16i. Again, we turn that I squared into a negative 1. 6 times negative 1 is a negative 6. Then we combine the 8 minus 6 to give us 2, plus 16i all over 20. Now we have 3 pieces. Those all are able to be reduced by a factor of 2. 2 minus 2 is 1. 16 divided by 2 is 8. 20 divided by 2 is 10. And we are done for today.